So what we use as for our technology here. So we have our backend is Elixir. I don't know here software engineers working Ruby on Rails or Python Django. I don't know what you guys stack. What do you guys use?
C++.
C++. Oh, that's naturally that's the one. You guys know the software engineers now. Okay, but anyway, I've used Django before, and I've worked in Django for 3 years. I worked in Ruby on Rails for a year. I did not choose Elixir because first Elixir is a functional programming language, and they're building for scalable and maintainable applications. And this is just on the website, to be honest, like a marketing kind of slogan here. So they build on top of Erlang VM, which is really interesting. And Erlang's been around for 30 years. And then some of the thing is they want Elixir try to bring this functional programming into build on top of this old technology, but which make it accessible. So Elixir was inspired by Ruby. It was inspired, but it's not really similar looking anymore. And started was because it was created by one of the core contributors of Ruby on Rails. Because the problem he had was he was managed on the Ruby on Rails stack is multi-threading. And he just couldn't make Ruby on Rails thread safe. So he started looking around a closure, different things, trying to see how people do concurrency in other languages. And then he fell in love with Erlang. But Erlang is kind of old, they have this little bit old kind of syntax and old kind of idiom of programming. So he kind of found that he can bring something new, so he created Elixir. So next one he uses Phoenix. Phoenix is a web framework built on top of Elixir. And so a lot of people think Phoenix is Ruby on Rails for Ruby, for Elixir, but it's not quite right. Phoenix is quite a lightweight framework. It's like a Ruby on Rails. It gives you a lot of conventions. There are a lot of generators. You can create a crawl up probably in 5 minutes. But at the same time, the layer is really thin. They become the functional programming language. You actually promoting function compositions, so you put the different functions together, you can easily trace back where it is. So if you look at a stack trace of Ruby on Rails, it goes through layers of classes. And so Phoenix is quite easy on that. And because the new framework is built on really modern kind of thinking, like what we need for running creating web applications. And then so because they built on top of Erlang VM, so you heard a lot of Erlang kind of benefits. For example, one thing about Erlang is Erlang is built by Ericsson back in 1986 and built for telecoms. And they have reliability of 9 lines. So they're down 5 minutes every year and a few hours last 30 years. And but also they created back in 1996, there was no multi-core computers. So what they did was they created this kind of thing for multiple devices. So they created this program language to run on either one or bazillion devices have no difference. So they have to create something. So they built this distribution layer called OTP, it's a toolkit for Erlang. So to manage this multiple processes, there's a supervisor in there, schedulers. It's like an operating system. They build themselves so you can manage different processes on multiple devices. So and then that just naturally fit in the new programming paradigm, because when the computing power increases, the more cores, but more cores is multiple CPUs put together. But a lot of languages like Python, Ruby, they actually can't take advantage of multi-core. So if you run a Ruby on Rails or Django a framework on a server, so what you need for multi-process, you need a system process. So for Django, probably can run 10 processes on a gig rack machine, and you probably can run about 8 or 7 Ruby or Rails on a gig machine. And then they're actually pretty slow as well. I did a comparison once in Web Summit. We needed to serve 30,000 attendees, simultaneously their API calls. So we need to handle about 30,000 requests per second kind of thing. And we had 27 servers, about pretty beefy machines, 4 gig RAM, 2 gig CPU stuff, and behind load balancer stuff, and the caching layer, different things. And then for the attendee API, I mimicked that, I created that in the Phoenix framework. I only need 1 gig machine to handle 30,000 concurrency requests. So obviously there's other things in there as well, like maybe not like accurate, but still, if you look at raw performance, like Elixir is a lot better. And because they're not built for distribution, so you can put them in multiple machines without actually doing extra things. So, what does Phoenix give you or Elixir provides you? Like a lot of people think, oh, it's a new programming language. It's quite new, it's a functional programming language. But it's quite mature, it's functional programming, that's first and foremost. And the second thing is they give you this like a code database layer. It's like ORM, but it's built in this kind of functional paradigm, and then it's easier to use. It's like I've been using Ruby on Rails and Django for many years, so I kind of looking for these things like to help me to manage my databases, because just like writing a lot of SQL, there's a lot of like SQL injections or different things you need to manage those. And the hex.pm is like a package registry, just like npm. They have a lot of packages on that. It's a pretty good community now. I interpolate with Erlang, which means you actually in Elixir you can call Erlang libraries. Erlang been developed for the last 30 years. There's a lot of different libraries in there. But Erlang never got so popular, so they never had a huge community. So a lot of like things is in the telecom layer. But because Elixir brings this kind of breeze in the new community here, so a lot of people from Ruby on Rails or Django kind of go into like they create a lot of new libraries. So on hex.pm you can see mix of different like communities, and that's great to see. You can see the good things from different communities. And the concurrency and distribution, just like I talked about, you can deploy like Phoenix servers on multiple servers, or one server with 8 cores, or 8 servers, 1 core. They're all the same. So it's kind of like give you this really stable throughput. And then it's easier to build kind of service-oriented architecture. So what that means is these days a lot of people talking about microservices like versus monolith. I'm still on the monolith side of things a little bit, but still I see the services, the benefits of using different services. And because Erlang is built on top, it's called message passing. So that's just like actually all the microservices does exactly that. So you have one service A talk to B, they either use TCP or use HTTP to talk to each other. And Erlang already have that built in. They have using this OTP layer. So what it does is you can write your like Elixir Phoenix app in one thing, and then because they're just function calls, and you can just replace one function with a service. And then that function they're calling a different service, and Erlang will manage that. And then so you don't need to worry about the thing. So which means you can just run, you can even have one monolith, and this server only run one service, and the other server running the other service, and they can talk to each other, no problem. And so it's kind of easy to give you productivity at start. You can create this monolith at startup, or like you spend a month to create this full-blown app, and then later, oh shit, we need more services, like we need to have multiple teams at different locations, so you can easily speed them up. And then also like Phoenix gave you this thing called umbrella project, which means you can create an umbrella, and then which you have multiple apps within, but managed by one app. So later in the future, you can just take one app out as a standalone app, have no problem at all. So that's really cool. And for the deployment as well, you can either deploy the monoliths, or you can just use the umbrella project. You can deploy them as like microservices in different machines, and one service on each machine. So Phoenix, because I said it's built for the modern web framework, so it's building API first class. So instead of if you look at the Django or Rails, the kind of API came afterwards. It was using the old kind of like managing not like API, you run a page and stuff. And so in Django, most people using Django REST framework. There's another abstraction on top, and then in Rails, people using Grape, or people using different Rails APIs. So just a different kind of abstraction layer, but Phoenix already have that built in. But if you want to build a traditional way of running just normal app, that's fine, you can run their pages. You have WebSocket supported first class, so that's what a lot of apps we created real time. So WebSocket is really important for us, so they have libraries like build the front end. And because the concurrency of Erlang is so good, so a good example is I think on 8 gig RAM machine for CPUs, like you can run about millions Erlang threads. So Erlang will take resources from the system, and they have their own scheduler, and they will spawn up like a multiple process for their own. But once it dies, it just like spawn another one. So which means if you have WebSocket, you have multiple like persistent layer talking between browser or phone, different thing to your backend. So you won't so you keep one thread only take a few K, so on the top different things. So you support multiple like WebSocket connections. The GraphQL support, GraphQL is a new thing a lot of people are reading about, it's pretty good. And then so there's the framework we built on top of Phoenix. async, so it's really good. And this is really, yeah, it's small. I don't want to really emphasize on this because benchmark sometimes really misleading, but it's to give you a general idea. This is a really old one. So for same machines, so the Phoenix can taking 43,000 requests per second, and Rails can take 3,000. So you can see the difference here, and even the latency itself is 2.1 milliseconds. So actually, normally, Phoenix or Elixir, they measure their response time in microseconds. They not even use they like just in general like just there's no latency at all. I don't know why. I think it's around thing, but so next thing we use front is React. So React, why we chose React is reusable components. So React built on this idea using build components and have a great community. React created by Facebook and then used by Facebook. Beta tested. I think there's not full Facebook site building using React, but there's a lot of them. They have 20,000 components built within Facebook, and then they have a great community. There's a lot of tooling built around it, so it's really good. And obviously there's compared to other frameworks like Angular or Ember, they all have a good community behind it. And I really like the data flow. React promoting is about this one directional data flow. It's called just a flux architecture, or we use a Redux. And so I did a lot of Angular before. I found that you find different places manipulate the same bit of data, so it can become really you couldn't figure out that when you have a bug and where it's coming from. So in React, it's really conventional, just one way go in there and goes back, goes in, goes back. And so next thing we use building mobile apps is React Native. The React Native, that's why we chose to use React in the first place. React Native is not hybrid app. It's not putting HTML or web builds into the mobile phone. Is actually the React itself is the core. So they have this thing called React DOM and React Native. React DOM is you using the core React and render to divs. So the DOM itself knows how to translate a component into proper platform. So you actually translate the views from the React Native to the native views of iOS, Android views, and our list views or different views. So they actually compile down to a native view. So performance-wise, actually pretty good. So it just gives you this UI building block, so you can have a component, and you don't need to worry about who renders to what, because that's managed by the different libraries. So there's actually AR kit building for React Native. You can build in AR, you can build in AR stuff using React Native, no problem. And people actually building games in React Native performance-wise, not as good maybe as the game engines, because there's actually no engine built for React Native, but it's still pretty good. And so the cool thing about this, you don't have the two teams from Object-C and Android, the Java to talk to each other, try to make them the things look the same or functionality-wise in sync. And then also, so we use this another wrapper around the React Native called Expo. Expo gives a lot of cool things. It's React Native, you still need to touch Xcode and Android for configuration. For example, you configure Facebook login SDKs. You do need you go into Xcode to do something. You need to go to Android SDK Studio to do something. But Expo actually give you all of that. They handle all those for you. But the only most popular kind of things, if you really need to go down to some modules you cannot use in JavaScript world, you have to go into Xcode or Android to do yourself. And Expo also give you some just not in the React Native core functionalities. For example, icons. We use font awesome, and I really use them for the whiteboard. So so that's those things, but it's not supported by React Native. So Expo team put them in and then configure the native module for that, and that works. And last thing is about Expo is cool thing about that is you don't even need to build the binaries on your own machine anymore. You actually have this Expo cloud. You can build IPA files or Android SDK files from the cloud. And also the push notification, they have this centralized SDK built in their SDK to help you to manage push notifications. And the best thing for me we're using is a code push. Because what it does, React Native works is it compile the view to the native view, but it runs this JavaScript core for managing the logic. So what it does is, for example, you have a list of news, just like I was talking about SIP. You have a list of news. But instead of render them by different support different orders, and you can change the orders. But in old way, you have to recompile your app. You upload the app store, just changing this order. But in using Expo or React Native in general, you don't have to. So you can push over there, just replace the JavaScript bundle, and you can send a request like to the thing, and then you replace the code. So Expo give you that like a code push, which actually Microsoft Azure have a code push as well. So you can actually replace the JavaScript logic code. Like you don't even release a new app. So sometimes we just push our app in, and we're fixing bugs afterwards. For the next 2 months, we don't even need to release a new binary because we only change is actually the core logic of the JavaScript. So that's really good, and that just so super fast. So like user have a bug, you can fix that in the next 5 seconds. You don't have to go through the whole app store review everything. And the other stuff we use here is Postgres, GitLab, AWS, pretty conventional ones. Except GitLab, obviously, like I think a lot of you are using GitHub. But I really think GitLab is a great product. It gives you like self-hosted like a solution, and then you can actually use the hosted ones, free ones, and you can use the paid ones like GitHub. And they actually have so many functionalities built in. They have a CI runner built in already, so you don't have to like use another service like Travis or whatever. And then so it's just, and it's free. It's a bit slow. It would kind of like it got bugs, like, but I think in general product-wise, it has more functionalities than GitHub. And I think that the best thing about this is actually GitLab bring in this computation in the Git management software, like like industry there. So now since the GitLab came on the scene, actually GitHub improved a lot. And AWS, yeah, that just we use. And so talking about all of this, like the productivity, where it's coming from, like React Native, it's not for us just about sharing the code, which you can. For example, between our web app and mobile apps, like we can, if the same like a kind of logic stuff, we can share nearly 60% of the code for logic bit. The view side is you can write your own views for iOS, a little bit like in JavaScript, but they're all in JavaScript. But it's more about sharing knowledge. Just like if you learn React, you learn this thing called JSX, a lot of people hate, but you grow like a love in it if you start doing it. And then so like so everybody knows JSX either on React Native or on React itself, and you can have a whole team. Everybody knows exactly the same thing. And the data flow, we use Redux. Again, share the libraries between different platforms, but the whole flow is the same. So if I'm only working on this web app, and some guy asks me to fix a bug in the native, like React Native bit, for me I can just dive in and find the problem because the whole convention is really the same. And the good practices, even though there are conventions, like there are conventions generally in Ruby on Rails, people still write bad code. So the thing is about improving. So like if I learn something new, we can do this to make React faster, and then I can share with the whole team, and the whole team just inherit the whole thing because whole practice is the same. No, people don't write the code in different ways. But I have to say React do have this it's easy to learn at the start. But it's really hard to get really good at because React have so many small things affecting performances to actually go in the way. So sometimes you can run an app really quickly, but it's super slow. And then you will say, oh, my React is shit because it's so slow. But it's not because the things you write in the wrong way, because React they give a really loosely kind of like a convention. So you do this, but there's a lot of good practice around it. You can make that a lot better. So that's why we chose those technologies. And I think I've been running my company for 2 years, and I work for this many companies, and then we also go into the perpetual things, writing share code, never get time to fix it. But it is good to create a technical debt for any technical product. It's okay to don't get it perfect at first time, just because sometimes you want to get that point, it takes time. And the second thing is a lot of times your product get defined over time, like you learn from business side of things, learn different things from users and you want to change it. So it's okay sometimes the solution is not the most optimal ones. But the thing is about going back to look at it every often. We did the first one, we did pretty badly, was we went back to refactor this code after 6 months. And look at who wrote this code? I didn't. But the thing that we sat down for like a week trying to refactor the whole thing, that didn't really work. We hated it at the end. And so we created this new practice. We just go back every week or two. We go one engineer we spend 1 day doing refactoring, just slowly improving the code base, and that worked out way better. And then so this that can be created, but you gotta pay back. So just remember this. I think that's why I learned to manage quality. And next thing is documentation. We didn't have documentation for the first half year, and then it's painful when we hand over the project. We spend a week writing documentations, and then we hate ourselves. Who wrote this code? I don't understand this. And then tests obviously give you confidence. We're refactoring things. And monitoring. We use CloudWatch on AWS, and then we also use Sentry to monitor our front-end code for JavaScript or React Native. And also our client using this thing called Hotjar, which is actually recording the UX, like how people use your site. That's really, really useful. So they record the whole thing. There's a bug happened. It's in those bugs, I don't know, it works on my machine. And they say, oh, there's a video. And they're like, oh, that makes sense. Oh, I never used it this way. So that's really good. So monitoring is really important. So last thing is our secret weapon. We use this text editor called SpaceMax. It's really old school. It's Emacs and with Vim bindings in it. A lot of people use it but the thing is, Sublime was cool, and then it wasn't cool anymore. Atom came out, and Atom was cool, and then Visual Studio Code came out, and Atom is not cool anymore. I know Emacs and Vim be there forever. So this is the first there's a distribution of Emacs which combine Vim and Emacs people together. So I think that's a lot of programmers and a really huge community. And I think when you have a company, I think the convention is really important. The practice is really important. If everybody on the same page for this, trivial things, so you don't have to think too much. Because if everybody using different editors, or this doesn't work, or that highlighting doesn't work, or yes, it doesn't work, all that kind of things, you might as well have one tool. If whatever it is, you should stick with one thing to help programmers to progress together and to share knowledge. So that's for me. All right, thank you. So
Jamie, just